Example 7. Given that 3y plus 2 over cos x dy by dx is equal to 1, find y in terms of x. Y is equal to 0 when x is equal to 0. So those are our boundary conditions. So let us see if we can solve this differential equation, get the general solution. All right, so if I separate the variables, I'm going to get 3y plus 2 dy is equal to cos x dx. All right. Now, if I integrate both sides, now 3y plus 2 is a linear factor. We can integrate a linear factor like this. We're going to say 3y plus 2. We're going to increase the power of the linear factor by 1, divide by the new power, and that's equal to, if I integrate cosine, I'm going to get sine. So this is sine x plus c. Next, I'm going to multiply both sides of the equation by 2. So I'm going to end up with 3y plus 2 all square is equal to 2 sine x plus 2 times c. C is a constant, so 2 times c still is another constant, so just simply change that to b. All right, the opposite of square is square root, so now I have 3y plus 2 is equal to the square root of, all right, before I go there, let's see if we can use the boundary conditions to find b. All right, the boundary condition says that y is 0 when x is 0. So boundary condition y is 0 when x is equal to 0. So now we have what? 3 times 0 plus 2 square is equal to 2 sine 0 plus d. All right. With a slight arrow, it's supposed to be 0 plus d. Now the sign of 0 is 0, so this goes 3 times 0 is 0, plus 2 is 2, 2 squared is 4. So what we have is 4 is equal to d, or d is equal to 4. So what we have is 3y plus 2 square is equal to 2 sine x plus d, which is 4. The opposite of square is square root. We have 3y plus 2 is equal to the square root of 2 sine x plus 4 divide by, so let us carry over positive 2. So now I have what? 3y is equal to the square root of 2 sine x plus 4 minus 2, and then divide the entire equation by 3. I'm going to get y is equal to 1/3 the square root of 2 sine x plus 4 minus 2 over 3. All right, so that's our particular solution. All right, this was example 7. Let's continue. Example 8. Example 8 says, given that dy by dx plus y squared sec squared x is equal to 0, find the equation of the curve which passes through pi by 2 minus a half. So pi by 2 minus a half are the boundary conditions. Pi by 2 is x and y is a half. So y is equal to a half when pi by 2 is equal to x are the boundary conditions. So let's just write dy by dx plus y squared sec squared x is equal to 0. I'm going to write dy by dx is equal to minus y squared sec squared x. Then let's separate the variables. I could say dy over y squared is equal to minus sec squared x dx. Then I can integrate both sides. So now I'm going to end up with y to the minus 2 dy is equal to, if I integrate sec squared, I'm going to get tan. So this is minus tan x plus c. All right, if I integrate y to the minus 2, I'm going to have y to the minus 1 divided by the new power minus 1 is equal to minus tan x plus c. So now what I have is what? Minus 1 over y is equal to minus tan x plus c. So I could multiply the entire equation by minus 1. So I'm going to end up with 1 over y is equal to tan x minus c. Now minus c, I could just simply change minus c to plus d, because if c is a constant, minus c is still another constant. So I just simply call the constant minus c, I just simply call it d. If I wanted to, let's invert both sides. I have y is equal to 1 over the tangent of x plus b. All right, let's go to our boundary conditions, or we could do it before here, but we can do it here. The boundary condition says y is equal to a half when x is pi by 2. All right, so again, the boundary conditions, y is equal to a half when x is pi by 2. I mean, I really sincerely believe that there's something wrong with this. I think that this should actually have been pi by 4, not pi by 2. All right, so y is equal to a half when x is pi by 4. So this is a half is equal to 1 over the tangent of pi by 4 plus b. All right, pi by 4 is 1. The tangent of pi by 4 is 1. So what we have is a half is equal to 1 over 1 plus b. Therefore, 1 plus b is equal to 2, and b is equal to 2 minus 1, which is 1. So my particular solution is y is equal to 1 over the tangent of x plus d, which is 1. That is a particular solution. All right, so there was an error in writing the question. The boundary condition was not pi by 2 a half. It was actually pi by 4 a half. All right. If it was pi by 2, you mean you'll encounter serious problems. All right. Let's see if we can have a quick look at example 9. Modeling problems. Example 9. So example 9 says, during a spell of ice rain, the ice on a windscreen has thickness x millimeter at time t hours after the start of freezing. At 6 p.m., after 2 hours of freezing, the ice on the windscreen is 3 millimeters thick. All right, so I'm going to make a note of that because it sounds important. So this is saying that x is equal to, well, x is the thickness, is equal to 3 millimeters when t is equal to 2. So the value of x and y here corresponds to a boundary condition. Let's continue reading. It says the rate of increase, so the rate of increase is proportional to 1 over x. All right, so the rate of increase is dx, there's no y here, dx by dt is proportional to 1 over x. Now, it's proportional to 1 over x is another way of saying it's equal to k over x. All right, so A is asking us to set up a differential equation, which we have. B is asking us to using the model, find the time at which the thickness of ice on the windscreen is 5 millimeters thick. All right, so let's solve our differential equation. We have what? X dx is equal to k dt. Integrate both sides. We're going to get x squared over 2 is equal to kt plus c. Here's another boundary condition. X is equal to 0 when t is equal to 0. All right, essentially that is saying just at the time, just before freezing starts, the thickness of ice was 0, which makes sense. If there's no freezing, there's no ice. All right, so that's all that statement is saying. So we can put that in and get 0 squared over 2 is equal to k times 0 plus c. And so therefore c is equal to 0. All right, so now what we have is x squared over 2 is equal to kt. We can use our other boundary condition, which says that x is equal to 3 when t is equal to 2. We can use this to determine k, which is the constant of proportionality. So this becomes 3 squared over 2 is equal to k times 2. So 2k is equal to 9 over 2. If I divide both sides by 2, I'm going to get k is equal to 9 over 4. And so I can therefore write my my particular solution to be x squared over 2 is equal to k, which is 9 over 4 t. All right, we still have that last part of the question to answer. So for that reason, I'm going to make t the subject of the formula. So I'm going to cross multiply and get 4x squared is equal to 9 times 2 is 18. So it's equal to 18t. Divide both sides by 18. I'm going to get t is equal to 2x squared over 9. Now, the last thing we're asked to do in B is to determine the value of t when x is equal to 5. So t is equal to 2 times 5 squared over 9, which is equal to 50 over 9 hours. So the value of t when the thickness of ice is 5 millimeters is 50 over 9 hours.